Hi, my name is Kayla, and I'll be talking to you about research that I did with Cynthia, Chris, and Seth on game behavior trees using tile rewrite rules. So what do I mean by that? What I mean is that a behavior tree controls the entire game flow of a game. So right from the initialization of a game, where we set the initial start state of the board, right through to a win condition for a player. And then the mechanics of the game are enacted using these tile rewrite rules. So for an example, wherever a pattern is found with player followed by a space to the right, that can be replaced by a space followed by a player to the right, which can implement a player being able to move to the right across the screen. And we've also included a bunch of little convenience nodes, convenient features to enable code reuse and organization. So an example you can see here is the X spin node. That's a transform node. That means that when the tree is enacted at runtime, all of those rewrites below it will be transformed to go in all four directions so that the player doesn't only have to be able to move right, they can also move left, up, or down. And that way, that saves a lot of time for the designer to not have to implement that 4 different times for virtually the same code. And there's a bunch of other conveniences like that you can talk to me if you see my poster. We did a bunch of case studies using this tool, enacting point and click puzzle games like Lights Out, block pushing games like Sokoban and Block Dude, board games like Checkers, turn-based RPGs and platformers like Turn Undead and Rust. And we also implemented some more experimental games that aren't necessarily the best way to use this tool, but were kind of an interesting way to test the limitations. So we made a text-based game using this tool. We made a turn-based version of the arcade game Pong. And we made Minesweeper as well. And we also made cellular automatas, which was very similar to Minesweeper in the execution, actually. We also made this web interface for editing games like this. So the designer can see the editing tree. They can see the tree with the transforms applied so that they can see how the tree will behave at runtime. They can use this middle field to edit nodes in the tree to create the patterns that are used in the rewrites and also move nodes around the tree. And they can play the game right in this same editor, including a mode where they can step through the tree so that they can see every node that's being executed as it's being executed to help them debug. Using this editor, we conducted a user study where we found that although people were really excited about it in their interviews, they really thought of a lot of potential for this tool. When we look at their task success rates and their usability scores, it's less encouraging. So there's definitely a lot of bugs to be worked out. And I have a number of theories about this that I'd love to talk to you about at my poster session. So if any of this was interesting, you can come visit me at the poster session. You can also come to this link, which has the code, the paper, the live editor, which includes all of those example games and more, which you can play with, edit, do whatever you want with. And I'd like to just conclude by thanking the Northeastern University Corey College Research Seed Grant for funding this research. And I hope to see you later at my poster.